AI is a broad field focused on using machines to perform tasks that typically require human intelligence. Machine learning, or ML, is an AI technique that's been around for decades, helping businesses address specific prediction problems. With traditional ML, data scientists identify key elements in a dataset and train a programmatic model to find patterns in that data. The model uses those patterns to predict a particular outcome when faced with new data. For example, is this transaction fraudulent? Deep learning is a subfield of machine learning, whose models are based on artificial neural networks. Neural networks have a layered structure resembling the human brain, allowing them to learn and model complex relationships between input and output data. Unlike traditional ML, deep learning models can handle more varied and unstructured input data. No one has to tell the model what to pay attention to. The neural network learns what's important through its training. Deep learning models excel at complex problems such as natural language processing or computer vision, and they're usually built to address a specific type of problem. For example, predicting the weather, translating text, or controlling self-driving cars. These models generally require more data, more training, and more powerful compute resources than traditional ML models. Generative AI is a type of deep learning that can actually generate new content, including stories, images, videos, and music. Generative AI relies on complex neural networks and very large models called foundation models. Foundation models are trained on massive amounts of data. Think everything on the internet. These models can produce generalized outputs. So you can ask a foundation model to do lots of different types of things. Examples include generating a product design, summarizing reports, generating code, or holding a conversation. You can also use a foundation model as the basis for additional training and specialization. Building a foundation model for generative AI is complex and resource-intensive. It requires very large amounts of cleaned and curated training data, powerful compute infrastructure, and considerable time and effort. These requirements make foundation models very expensive to develop from scratch. But luckily, there are now foundation models available for you to use without making that investment.